This is Bob Capetta from the College of the Florida Keys, and this lesson is on multiplying algebraic fractions. We're going to start with reducing fractions. So we're going to look at one from arithmetic, 24 divided by 30. And the way we're going to reduce these fractions is to factor and then divide out. So factoring 24, 24 is 8 times 3, or 2 times 2 times 2 times 3. Those are the prime factors. So we rewrite numbers as a prime factorization. 30 is 6 times 5, or 2 times 3 times 5. Now you notice that 2 over 2 is the same as 1 over 1. And 3 over 3 is the same as 1 over 1. So it appears as if I'm canceling. I get that. But think of these things as ones. That this crossed out 2 is a 1. This crossed out 2 is a 1. That becomes 1 over 1. This crossed out 3 is a 1. This crossed out 3 is a 1. So upstairs we have 1 times 2 times 2 times 1. Downstairs 1 times 5. Putting all that together, then we're left with 2 times 2 over 5, or 4/5. Now the process is the same when we jump to algebraic fractions. So if I have 10x cubed y to the 7th over 15x to the 4th y to the 11th, I want to think about how I can factor this so that I get some 1 over 1 situations. Well, the first thing I did was I rewrote x to the 4th as x to the 3rd times x to the 1st. Notice that will divide out the x to the 3rds. And I rewrote y to the 11th as y to the 7th times y to the 4th. That will divide out the y to the 7ths. So you'll notice x to the 3rd over x to the 3rd is 1 over 1. Y to the 7th over y to the 7th is 1 over 1. So upstairs we have 10 times 1 times 1. Downstairs 15 times x times y to the 4th. But we're not quite finished because, of course, I can reduce 10/15ths. Divide 10 by 5, I get 2. Divide 15 by 5, I get 3. And I can think of it that way. So I prefer to deal with the variables first and then go ahead and look at the constants. So continuing our discussion on reducing fractions, again, since that is the major process of multiplying fractions, I've got 6x plus 12 over 5x plus 10. Now these are binomials. So I have to look at what factor goes into both pieces. Into both 6x and 12, I can factor out a 6. Into 5x plus 10, I can factor out a 5. So we get 6 times x plus 2 over 5 times x plus 2. And you will notice x plus 2 over x plus 2 is the same as 1 over 1. So I think of those as 1 over 1. 6 times 1 is 6. 5 times 1 is 5. And my answer to that is 6/5. Our next case is reversed subtraction. So x minus 7 and 7 minus x are not the same thing. 2 minus 5, 5 minus 2, not the same thing. But they are related. The way to think of this is to divide a -1 out of one of them. So if I divide a -1 out of 7 minus x, what do I get? I get -1 times -7 is +7. -1 times x is -x. So I've successfully divided out a -1. So now I get x minus 7 upstairs and -7 plus x downstairs. Notice those are the same thing. X minus 7 is x plus -7. -7 plus x is x plus -7. Reversed addition are the same thing. 2 plus 5, 5 plus 2 are the same thing. So indeed, x minus 7, -7 plus x can be thought of as 1 over 1. So the top now is 1, the bottom is -1 times 1, the bottom is -1. So we get 1 over -1, which is -1. Next up, I get x minus 7 over 3x minus 21. Let's go ahead and factor out a 3. So what do we get there? X minus 7 over 3 times x minus 7. And of course, again, x minus 7 over x minus 7 is 1 over 1. So upstairs I have 1, downstairs I have 3 times 1, and the result is 1/3. So we're still reducing these things, getting us ready to multiply, but let's look at a situation like this. X squared plus 8x plus 16 over x squared plus 5x minus 24. Factor each of these. The top one is x plus 8 times x plus 2. The bottom is x plus 8 times x minus 3. In which case we have x plus 8 over x plus 8 can be thought of as 1 over 1. So 1 times x plus 2 over 1 times x minus 3 gives me x plus 2 over x minus 3. And I have one more reducing problem to look at. 3x plus 6 over x cubed plus 8. 3x plus 6, 3 times x plus 2. X cubed plus 8, a sum of two cubes. X plus 2, x squared minus 2x plus 4. So now you'll notice there's an x plus 2 on the top and the bottom. Think of that as 1 over 1. So if that's the case, 3 times 1 upstairs, 1 times x squared minus 2x plus 4 downstairs. And we get 3 over x squared minus 2x plus 4. But everything we've done so far has been reducing fractions, and you will see that multiplying fractions is really the same argument. So if I have 26 over 25x cubed times 15x to the 6th over 2, we are going to use essentially the same process as reducing. Factor 26, 2 times 13. 25, 5 times 5. 15, 3 times 5. 2 is 2. X to the 6th and x to the 3rd, we can factor them in multiple ways. So this is what I have currently. And you'll notice what I did with x to the 6th. I made it x to the 3rd times x to the 3rd, so that x to the 3rd over x to the 3rd can divide out. Also notice when I multiply fractions, we can write it as a single fraction, 2 times 13 times 3 times 5 times x to the 6th over 5 times x cubed times 2. Now, we look for what's the same on the top and the bottom. 2 divides 2, 5 divides 5. X cubed divides x cubed. What's left? Upstairs 13 times 3 times x cubed times a bunch of 1s. What's left downstairs? 5. So that my final answer will be 39 x cubed over 5. So again, you'll notice the process of multiplying two fractions is essentially identical to the process of reducing a fraction. But these are all monomials. The more challenging question is this when we have polynomials to work with. And our process is going to be to factor each piece. X squared plus x minus 30, x plus 6 times x minus 5. 9 times x plus 1, factor out the 9, 9 times x plus 1. X squared plus 2x plus 1, x plus 1 times x plus 1. X squared minus 25, x minus 5x plus 5. So now we have this fraction times this fraction. We can write it all as a single fraction. So x plus 5 times x minus 5 times x plus 1 times x plus 1 over 9 times x plus 1 times x minus 5 times x plus 5. Now what's the same on the top and the bottom? It looks like x minus 5 over x minus 5 can be thought of as 1 over 1. It looks like x plus 1 over x plus 1 can be thought of as 1 over 1. X plus 6 times 1 times x plus 1 times 1 gives me x plus 6 times x plus 1 upstairs. 9 times 1 times 1 times x plus 5 gives me 9 times x plus 5 downstairs. And I'm okay with you expressing the answer that way. You certainly could multiply things out to say x squared plus 7x plus 6 over 9x plus 45. But I'm satisfied with this format here. Okay, our next example. 18x minus 12 over 4x squared times x squared minus 4x plus 5 over 3x squared plus x minus 2. So we need to factor each piece. 6 comes out of this piece. So 6 times 3x minus 2. This one, x minus 5x plus 1. 4x squared we're going to leave alone for now because it's a monomial. 3x squared plus x minus 2, a little more challenging, but that's 3x minus 2 times x plus 1. Use the factor puzzle if you need to. Now we have, in the top, 6 times 3x minus 2 times x minus 5 times x plus 1. On the bottom, 4x squared times 3x minus 2 times x plus 1. And we ask ourselves, what is the same on the top and the bottom? 3x minus 2 and 3x minus 2 becomes 1 over 1. X plus 1 over x plus 1 becomes 1 over 1. Now upstairs I have 6 times x minus 5. Downstairs I just have 4x squared. But this is not finished because 6 over 4 can reduce. If I divide 6 by 2, I get 3. If I divide 4 by 2, I get 2. So I get 3 times x minus 5 over 2x squared. Again, I'm satisfied with that, although you certainly could write it as 3x minus 15 over 2x squared if you would prefer. So you'll notice that multiplying algebraic fractions is the exact same process as reducing algebraic fractions. So I've got one more case to look at, and that's division. Remember, if you're dividing fractions, you multiply by the reciprocal. Change the division to multiplication and flip the fraction that follows the division sign. So we will rewrite this as x squared minus 7x plus 12 over x squared minus 3x minus 4 times, flip it, x squared minus 49 over x squared minus 10x plus 21. At this point, we need to factor everything. X squared minus 7x plus 12 becomes x minus 4 times x minus 3. X squared minus 3x minus 4 is x minus 4 times x plus 1. X squared minus 49, x minus 7, x plus 7. X squared minus 2x plus 21, x minus 7 times x minus 3. So I factored them, and then I wrote them together as a single fraction. So here's the factored version, x minus 4, x minus 3 for this piece, x minus 4, x plus 1 for this piece, x minus 7, x plus 7 for this piece, x minus 7, x minus 3 for this piece. Putting them all together, x minus 4, x minus 3, x minus 7, x plus 7 on top, x minus 4, x plus 1, x minus 7, x minus 3 on the bottom. What is the same on the top and the bottom? X minus 4 over x minus 4 becomes 1 over 1. X minus 3 over x minus 3 becomes 1 over 1. X minus 7 over x minus 7 becomes 1 over 1. So what does that leave us on top? 1 times 1 times 1 times x plus 7. 1 times x plus 1 times 1 times 1. So x plus 1 on the bottom. So that our final answer will be x plus 7 over x plus 1. And that will conclude this lesson.